The problem within the first-year lab workstation is that the current open bin system in the first-year lab has fostered issues with excessive hardware acquisition and inaccurate sorting by students, ultimately leading to wasted materials. The solution was a hardware sorter and dispenser. This is a custom vending and sorting machine with a credit-based system to track hardware dispensed and returned by students. This solution will help regulate hardware usage, reduce waste, ensure accurate sorting, and promote a fair distribution of resources. The stocked hardware includes screws M3x8, M3x16, M3x30, and M3x15. This also includes an M3 nut, an M3 lock nut, and an M3 flat washer. The sponsor also strongly desired an M2x10 with an M2 nut to support the sonar sensor that is included in the first-year lab kit. The key specifications include a budget of $3,000, ADA compliance to Section 308, dispensing accuracy of plus or minus 15%, credit tracking accuracy of plus or minus 10%, a jam rate of plus or minus 1%, and to stock at least 1,000 units of each type of hardware. The major obstacles included ADA reach compliance, which states that an acceptable reach range is between 15 and 48 inches above the ground. This is for both forward and lateral reach. Another obstacle was cost constraints. Working within a $3,000 budget was particularly challenging as it limited the materials and resources available for designing a reliable system. For this reason, many components were sourced from the GVSU machine shop and were either 3D printed or laser cut from acrylic. 3D printing had also posed specific limitations with this project. The reliability and time associated with 3D printing posed a significant challenge during the build portion of the machine. The tolerances of 3D printing are not as precise as other fabrication methods, which resulted in multiple iterations of prints before finalizing many component designs. Next, we will discuss the subsystems of the hardware sorting and dispensing machine. The intake and indexer utilizes an electromagnet which can be activated or deactivated to attract ferromagnetic objects. This works as an initial method to sort out trash. Items that are attracted to the electromagnet are rotated and then placed onto the indexer, which limits the amount of hardware that is directed towards the conveyor system. The conveyor system consists of a 3-tier conveyor that separates parts operating at 3 different speeds. On the final conveyor, a vision system identifies the hardware and signals the distribution ramp to rotate. Separation between hardware is essential for the vision system to accurately detect and sort a single object. The vision system utilizes YOLO V8, a Python package of a computer vision model created by Ultralytics, with a custom trained model based on stocked hardware. Over 3,000 images of the stocked hardware were taken to create this model. Identification of the vision system signals the distribution ramp and keeps track of the hardware count within the system. The distribution dish is what directs hardware towards their corresponding film reel. Object detection from the vision system signals the distribution ramp to rotate to the corresponding distribution cup. Any unidentifiable objects are directed to a larger cup that is designated for trash. From here, transportation tubes are connected between the distribution dish and the film reels to move hardware through the system. The film reels were created as they were a great solution to both storage and distribution of the hardware. Each film reels basin holds 1,000 units of a disc featuring cutouts matching the hardware shape. When dispensing, there is an inner disc that rotates to pick up the hardware at the bottom of the basin and releases the hardware through a hole that is cut out at the top. A photoelectric infrared sensor is what detects the hardware on the back side of the film reel as it falls out and corrects the count of the dispensed units. There are 3 sized film reels, but they were all initially based off of the medium-sized film reel, which was the initial design. The smaller film reel was created to help prevent jamming of some of the smaller components, which include the washer, the M2 nut, and the M2x10 screw. The larger film reel was created to solve a volume issue that was noticed when trying to stock 1,000 units of the M3x30 and the M3x50 screws. The user interface is what enables students to retrieve and return hardware using their building keycards. Credit is added to the keycard for return materials, and credit is subtracted when materials are retrieved from the system. Credit is applied to each student's card and tracked through their returns and their retrieval of hardware through the machine. A 10-inch touchscreen and an RFID scanner were used to create the user interface. The control system uses a Raspberry Pi 5 to communicate with two Arduino Megas via a UART serial communication. The Raspberry Pi 5 handles the user interface image recognition, while the Arduino Mega manages sensor inputs, outputs, and motor controls. The motor controls for the dispensing reels are split between two Arduino Megas due to the limited PWM pins. 8 bridges are used to control motor speed independently based on the PWM signals from the Arduino Megas.